Good morning to all. I am Sumati. Going to discuss in this video. I am going to discuss about one-bit sliding window protocol. Before going to the concept of one-bit sliding window protocol, we can let us know about what is sliding window protocol. This is a key concept used to control the flow of data between any two devices, that is the sender and the receiver. The main focus of using this sliding window protocol is it, it gives us an effective delivery and reliable delivery of data packets from any uh, between any two devices, and it maximizes the available bandwidth. Sliding window protocol is mainly used for obtaining the reliability of data packets. This is a part of the OSI model, and it is made use in data link layer protocol. Sliding window protocol handles efficiency issue by sending more than one packets at a time with a larger sequence number. The idea is the same as pipelining in RTER. Pipelining architecture is nothing but we can send multiple data packets without waiting for the acknowledgement for each and every individual packets. This concept is more efficient in terms of communication channel, as the sender can keep the pipeline of data flowing rather than waiting for the confirmation of each packet before sending the next. This is the non-pipelining architecture versus pipelining architecture. In non-pipelining architecture, the sender between the client and the server, whenever the client sends any packet to the server has to acknowledge. After receiving the acknowledgement alone, the client can again retransmit the second frame. Whereas in pipelining techniques, the client can send any number of packets at a time without receiving the acknowledgement for the packets being sent already. This is how the retransmission of takes place through pipelining architecture. We have another concepts called piggybacking techniques, which is used in full duplex channels. Piggybacking is a technique of delaying outgoing acknowledgement temporarily and attaching it to the next data packets. When the data frame arrives, the sender waits and does not send the control frame, that is the acknowledgement, back immediately. The receiver waits until its network layer moves to the next data packet. The acknowledgement is associated with this outgoing data frame. Thus, the acknowledgement travels along with the next data frame. This is the full duplex channel that transmission takes place between in both direction. In simplex means the transmission takes place only in one direction, but here full duplex means the transmission takes place between the sender and the receiver in both directions. Here the sender is the host A and the receiver is the host B. The sender sends the data packet. The host B receives the data packet, and when it has to send the data to host A alone, it acknowledges the first frame being sent. Here the acknowledgement travels freely along with the data frame sent by the host B to host A. Hence, this technique of sending the data frame along with the acknowledgement data frame and the acknowledgement to host A is said to be a piggybacking technique. Here the acknowledgement takes a free ride along with the data packet to be sent to the host A. This technique is said to be as piggybacking. Terminologies related to sliding window protocols are transmission delay, propagation delay, efficiency, effective bandwidth, and capacity of the link. Working of sliding window protocol: the sender sends the data frame according to the specified window size of the sender, and the receiver receives the data frame according to the specified window size. The range of sequence number depends on the size of the data frame n. So the range of sequence numbers can be between 0 to 2 power n minus 1. Steps of data transmission. The sender sends the multiple frames. The receiver receives the frames and sends back the acknowledgement. Again the sender sends the next frame. If the receiver does not send back the acknowledgement in the specified time, then the sender sends back the frame as the frame is considered as lost or damaged in the last transmission. This process is continued till all the frames have been received by the receiver. This is how the transmission takes place in the sliding window protocol. Here the window size is 4. So 0, 1, 2, 3 and 4 frames are being in the sender's window, sliding window. Here the 4 frames are being transmitted at a time, and we are receiving the acknowledgement for the 0th frame, that is sequence number 0 is used here, and we are receiving the acknowledgement for the 0th frame, after which the 4th frame will also be sent. Here how the 4th, as we have received the acknowledgement for 0 and first frame, we are transmitting 4th and 5th frame here. This is how the transmission takes place. The sending's window size is 4 and the receiver's window size is also 4. So we are sending 0, 1, 2 and 3 frame, and the receiver's window receives 0th frame. After receiving 0th frame, it sends back the acknowledgement for 0th frame. After receiving the acknowledgement for 0 and first frame, the sender sends for again 0 and first frame. And after receiving the acknowledgement for second frame of 2301 is also being sent. After receiving the acknowledgement of second frame, 301 is again being sent, and we are receiving the acknowledgement for third sequence number, and we are transmitting 0, 1, 2 and 3 again. This is how the transmission takes place by using sliding window protocol. Here the blue color box indicates the sliding window, which moves from 0 to 10 the frame, 1 bit at a time. After this, the frames within this box indicates the frames being sent but not acknowledged. 0, 1, 2 and indicates that the frames already sent and being acknowledged. 7, 8, 9 and 10 indicates that the frames not yet sent. Conclusion: the sliding window protocol is a data link layer protocol that is useful for sequential and reliable delivery of data frames. It is used as TCP, that is Transmission Control Protocol. Using the sliding window protocol, the sender can send multiple frames at a time. The sender associates a sequence number to the data frames so that the receiver can use the sequence number to arrange the frames in order if any frame was retransmitted. The sequence number also helps the receiver to identify the loss of damaged packets. When the receiver receives the frame, it sends back an acknowledgement or acknowledge to the sender. The acknowledgement lets the sender know that the particular frame is received by the receiver correctly. Thank you.